breather valve sits on the sump, with the primary function of alleviating pressure build-up within the crankcase by equalizing with the atmosphere. The pressure build-up is caused by the leakage of gases from the combustion chamber that makes its way into the crankcase. By not alleviating the pressure, unburnt fuel and waste will mix with the oil, causing a sludge or a reduced quality of oil that will no longer lubricate efficiently. Additionally, a build-up in pressure could cause leaks into further parts of the motor, damaging important seals and reducing the effectiveness of the motor. The properties required come down to two simple features. Firstly, it must have a high melting point due to the venting of hot gases from the crankcase. The material used must be able to withstand these temperatures and retain its structural integrity. Secondly, it must be fatigue resistant due to the high vibration environment of the engine, as it must be strong enough to not deform over time and continually fulfill its function of reducing pressure inside the crankcase. From inspection of the breather valve, it is evident that the part was produced in sequential stages using a variety of metalworking techniques. Firstly, the two halves of the valve both contain cavities, with evidence of wrinkling, suggesting that these cavities were formed using the technique of deep drawing. There is also a contoured base, which, in deep drawing, would be formed by the punch pushing the sheet metal into the cavity. Holes at the ends of the components suggest that blanking has occurred to form them. Lastly, one half of the valve is joined to the other half via seaming, which is indicated by one piece being folded over the other. The external part of the breather valve contains two pieces of sheet metal that have been worked into a particular shape and then put together. Firstly, one piece of metal is stamped to form the required pattern. This is done first as stamping is difficult for objects with complex geometry. Once this has been done, each piece is then deep drawn to their respective depth. The holes on the sides of each piece, as well as the hole on the bottom of the pattern piece, are then removed through blanking. Drawing is done before the blanking, as it may cause deformity of the holes. Any components within the valve are then added before two opposite edges of one piece are folded over the other piece, forming a seam and joining the pieces together.